Hi students, in this video we are going to discuss about plane angle, solid angle. Now first plane angle. Our first concept is plane angle. Now take an arc. It is an arc. Consider it is d theta. Now it is ds. Here ds is equal to length of arc. This is called arc. Length of arc. Now d theta is equal to small angle. Small angle. Now go for the discussion. The ratio of length of arc to the radius is called plane angle. Now consider it is the radius r, where r is equal to radius. Once again I am explaining the ratio of length of the arc, that means ds, to the radius r is called plane angle. Now it can be write as the d theta is equal to ds by r. Once again, the ratio of length of the arc to the radius of the circle is called plane angle. Now arc is equal to d theta into s. Please keep mind the gap. But the plane angle formula is equal to the ratio of length of the arc to the radius is called plane angle, which is denoted by d theta. Which is denoted by d theta. Now the unit of plane angle is radian. Once again, my dear students, the unit of plane angle is radian. These are the points we have to remember. Once again, here the main point is d theta is equal to ds by r. Consider equation number 1. This is important. Please keep in the bracket. Now plane angle, which can be defined as it is the ratio of length of the arc to the radius, is called plane angle. Now we are going to discuss about solid angle. Solid angle. The solid angle denoted by d omega. Now take a sphere. In the sphere, I took one radius. Now, take here from this one, we have to draw an angle which is this angle. This angle we can call as solid angle, that is d omega. It is O. This is the radius of the sphere. This is the area, that is dA. Now take a sphere. In this, R is equal radius dA is equal small area of the sphere of a piece. Now d omega is equal angle subtended at the center of the sphere by a area angle. Now go for the definition. The ratio of the intercepted area dA of the spherical surface described about the apex O. Now yes, the center of the square of its radius small r. Therefore, now its unit is, first its formula is d omega is equal to dA by r square. Consider this is equation number 1. Once again, the ratio of the intercepted area dA of the spherical surface, it is a sphere. So spherical surface described about the apex O. Yes, the center of the square of the radius is called solid angle. Now, once again I am repeating the point, my dear students. The radius of the intercepted area dA of the spherical surface described about the apex O. Yes, the center of the square of its radius R is called solid angle. It is denoted by d omega. It is denoted by d omega. Therefore, d omega is equal to dA by R square. Consider equation number 1. Next point. Its unit is its unit is steradian. Its unit is steradian, which is denoted by S, capital S, small r. Its unit is steradian. Its unit is steradian, denoted by capital S, small r. Now, we are going to discuss about measurement of length. Measurement of length. A meter scale is a meter scale is used for length. Length from 10 to the power of minus 3 meters to 10 to the power of square meters, that is millimeter to meter. Once again I am repeating this point, my dear students. A meter scale is used for length from 10 to the power of minus 3 meter to 10 square meters. Next point. A vernier calipers A vernier calipers is used for length to an accuracy of 10 to the power of minus 4 meter. My dear students, once again I am repeating this point. A vernier calipers is used for length to an accuracy of 10 to the power of minus 4 meter. Next point. A screw gauge and a sperometer can be used to measure length. Measure the length as less than less than 10 to the power of minus 5 meters. Once again, I am repeating this point, my dear students. A screw gauge, it is an equipment, and a sperometer, it is an equipment, can be used to measure length as less than 10 to the power of minus 5 meters. Now, measuring of our setting is measuring of large distances. Measuring of large distances. Now I would like to explain point by point. Please observe carefully. Now, once again, our concept is measuring of large distances. Measuring of large distances. Point number 1. Large distances. Large distances. Large distances such as planet, or stars, such as planets or stars from earth, from earth can be measured, can be measured by the parallax method. Once again, I am repeating this point, my dear students. Large distances such as planet or stars from earth can be measured by the parallax method. Parallax method is important. Now go to point number 2. Point number 2. To measure the distance, to measure the distance d of a faraway planet yes, by the parallax method, we observe it from two different positions. two different positions A and B. A and B on the earth. On the earth. On the earth. Separated by distance separated by a distance B, that is AB is equal to B. At the same time, we measure the point number 3. Once again, I am repeating this point, my dear students. To measure the distance d of a far away planet S by the parallax method, we observe it from two different positions A and B on the earth, separate by a distance AB is equal to B at the same time. Now I can draw a diagram to make you understand easily. Now take, this is the A, this is the B, consider it is a small b, consider it is S, it is the angle, here it is D, this is also distance, same distance D, it is the angle theta, here B by D, B, this is B by D, always less than 1. This condition should be satisfied. Actually, this is also we can consider as a arc. No problem. So, arc. This condition should be satisfied. Consider this is point number 3. So, this statement supports this diagram. Now, point number 4. We measure the angle. We measure the angle between the two directions along which the planet is viewed yet these two points therefore point number 5, angle ASB represented by symbol by symbol theta. By symbol theta is called the parallax angle. Is called the parallax angle. Once again I am repeating this point. Parallax angle, or the another name is parallactic angle. Parallactic angle. Now once again I am repeating the point, my dear students. Angle ASB represented by the symbol theta is called parallax angle or parallactic angle. Okay, now go to the next point, number 6. If the planet is, if the planet is very far away, therefore B by capital D less than 1. Once again, if the planet is very far away, therefore B by capital D less than 1. Now point number 7. If theta is very small, then we approximately take AB as arc of length B of a circle with center yet yes and the distance D and the distance capital D as the radius as the radius AS is equal to BS. Therefore AB is equal B, that is equal d theta, capital D theta. Once again I am repeating this point. If theta is very small, then we approximately take AB as arc of the length B of a circle with center at S and the distance D as the radius. Therefore AS is equal to BS. Since AB is equal B, that is equal d theta. Now point number 8. Therefore AB is equal to B, that is equal d theta. That implies theta is equal B by capital D, where theta is radian, where theta is radian. Therefore capital D is equal B by theta. Consider equation number 1. Now point number 9. Once again I am repeating this point. AB is equal to B, that is equal to d theta. Theta is equal to B by D, where theta is radian. Therefore D is equal to B by theta. Consider equation number 1. Now see the diagram. Once again I am draw the diagram here. Take it is a radian, or take a straight line. Imagine this is A, this is B, the distance between them is small b, it is capital D, it is also capital D, it is the theta. Now it is nothing but yes, this is the diagram for that one. Now come to the point number 9. Similarly, you suppose I can take like this in reverse one. If the vertex is here, consider it is alpha, it is capital D, it is capital D, it is small d. In this case, alpha is equal D by capital D. Okay, alpha is equal, this is called radian. Now angle is equal radian by radius. So small d by d. What is the formula? Angle is equal angle is equal, what is the formula? Arc by radius. Arc by radius. From this formula we can write that alpha is equal small d by capital D. That means point number 10. Similarly, we can determine the size or angular diameter of the planet. Once again I am repeating this point, my dear students. Similarly, we can determine the size or angular diameter of the planet with this diagram. where small d is equal diameter of planet and alpha is equal angular size. Angular size. Angular size of the planet angular size of the planet, the angle subtended by the angle subtended by small d at the earth Once again, I am repeating the point where alpha is equal to angular size of the planet, the angle subtended by d at the earth. So, this is about measurement of large distances. Next video, we will do some numerical on this basis. However, thank you very much for watching this video. Thank you. This is part 2 video. No need. Thank you.